Hi, my name is Alex Loera, and my presentation is on the Paleocene. So that is 66 to 56 million years ago. As far as the timeline, it falls underneath the Phanerozoic Eon, the Cenozoic Era, the Paleogene period, and it is right next to the Eocene epoch, which is right next to it in the future, and it's just coming out of the Mesozoic. So the Cretaceous had just passed. Right, so what just happened? There was a very big extinction, probably one of the more popular ones. It is the Cretaceous Paleogene extinction, also known as like the KT extinction. This is the one that most people know about because it is the one that with the extinction of dinosaurs. It's the second biggest of the big 5 mass extinctions, and it is actually the only one that corresponds to a meteor impact. So everyone always thinks of extinction being because of a meteor, and this is the only one that actually has that related to it. So the eruption of the Deccan volcanoes in India, it's thought that this meteor impact actually activated these volcanoes, kind of woke them up, and they just started spewing out lava. One man writes, it's Robert Sanders, he writes that it's about 30 times the amount of the activity that we have today in Hawaii. So that's what was happening with these volcanoes. And so both of these are contributing factors to a possible nuclear winter, is what most people believe is what happened, that it was just this nuclear winter because of these other things, and that's what caused this extinction. So what is in the air? So we are coming out of a nuclear winter, so it is a little colder at the start of the Paleocene. However, there is a big event that goes on towards the end. It's the Paleocene-Eocene thermal maximum, or the PETM, and it was just this huge spike in carbon levels. It got really hot, and it transitioned the nuclear winter to a greenhouse effect. And as far as the water, there's studies that have found huge amounts of carbon that was absorbed in the water. So temperatures and acidity, like all the pH levels, they really fluctuated in this time period. So in the Paleocene, they really fluctuated. There were some signs of life though. There were mollusks, crustaceans, and corals. So who else is there in the Paleocene right now? So coming out of this big extinction, most of the dinosaurs did not make it. There's different ideas as to why that is. So one of the things is that maybe just their size, that there wasn't enough resources to go around, so they just didn't make it. But one animal that did make it through that boundary, so from the Cretaceous into the Paleocene, was actually the mammals. The mammals did really well in the Paleocene. In particular, the placental mammals, they did really good in this period. Along with them were marsupials, such as the Pucadelphis anitus. They had multi-tuberculates like the Tilidus, which was like a squirrel or a beaver. I mean, most similar to that. We also had the monotremes, such as the Monotrematum pseudomericanum. So yeah, we had those. There's also evidence of the Waimanu, which is kind of the link for penguins from flying birds to what we have today, where their bones are so stocky that they really can't get up in the air. They don't have the right aerodynamics for that. So yeah, I mean, mammals really thrived in the Paleocene. Really diversified. You have primates coming out of this, so that's what's going on right there. We also have a very good example of coevolution. So basically what that is when two species go hand in hand with each other and they really help each other thrive. And so what we did see at the beginning of the Paleocene was a huge spike in angiosperms, which is flowering and pollinating flowers. So for those to survive, you need insects to pollinate them. You need the pollinators. So these flowers are thriving off of these pollinators. The pollinators are thriving off of flowers. So they really go hand in hand. They did very, very well in this time period. As far as the continents, we were at the beginning of the Paleocene. We are almost at our current position. There's still a few things, like Greenland is still connected to North America. The Atlantic Ocean is not near as wide. You still have Australia that is not isolated yet. India is still down south, so it hasn't moved yet. Okay. And then as far as plate tectonics, there was a lot of rifting. So that's where you do see that, during the Paleocene, that Greenland starts separating from North America. You have the Middle East kind of separating from Africa. And then you also have the Atlantic Ocean finally widening. And half of the ocean floor that we currently have today is actually from this Cenozoic era. So this is where we see most of that rifting happening, at least from what we have today. Okay, and they will also have some collisions going on. So there's some collision with Africa and Europe, and then there's also collision with with India going to Asia. It doesn't collide right now in the Paleocene. That happens later. But it does start moving, and it starts moving fast. So that's where we start to see that speedy little guy heading up towards there. And there's also collisions between plates. So our next slide is orogenies. So the Laramide orogeny is continuing from the Mesozoic, and you have this subduction of the Farallon plate going under the North American plate. And so what that is causing is a feature of basins and ranges. So one of these basins being Badwater Basin. So if you've seen that, and then the Rocky Mountains. So we do see a lot of mountain building on the west coast in the Paleocene time. Okay, so why is this time period significant? Well, it's really a recovery period. It's the first epoch after this big extinction, so we did see a lot of animals that most people know, as prehistoric, that just didn't make it past that boundary. So it really is, it's a time of recovery. And along with that, there's a lot of fluctuation in temperatures and stuff. So this is at the end of the Paleocene where we start to see that greenhouse effect, which we're no longer in right now. But there was that time period where we had that greenhouse effect not too long ago. And as far as California, it's very significant because that's where most of California's geologic history takes place. So we have a lot of that subduction just creating these mountains. And yeah, it's scenic. It's what we know as California. And yeah, that is the Paleocene. Thank you.